class, and today I'm going to discuss with you how the mathematics and analytical operations of operations research can be used to solve problems in marine engineering and shipyard management industry today. So, before we get into how operations research relates to the shipyard management and marine engineering industry, we'll start off by just asking what operations research exactly is. So, operations research is defined as the application of advanced analytical methods to make organizations operate more efficiently with objectives of primarily reducing cost and maximizing profit. Some of the topics that we covered in class regarding operations research include decision making trees, Bayesian theorem, utility theory, Markov chains, and queuing theory. We'll get into more of these topics later in the presentation, but operations research is essentially just making sure which route is the best route for us in terms of profit or cost. It really depends on what the situation asks. And now we will get into the application of operations research and mathematics to the maritime industry. So, just as we said before, that there are some uh, tools that we can use in operations research to help us make these decisions regarding which route is most profitable, most cost effective. Some of these we mentioned before, such as decision making tools, which, to be more specific, is utilizing decision trees, which are essentially branches that tell probability of each outcome or decision, and as well as the consequences or outcomes that each decision has. The list of these potential outcomes helps to also tell if using this method or option is the best one or the worst one, and it can also tell, depending on how what the probabilities say, how likely it is of being successful or failing. Another thing is queuing theory. Queuing theory, it essentially is divided up into different models, and each model has its own set of parameters that allow them to be used. Essentially, queuing theory, it's beneficial in that it helps model the operation of queues and servers within the whole system. These models are used to help promote efficiency in a system. They can also be used just like decision making tools, determine the cost and profit of the current system or queue that's being used. Next up is Markov chains. They're essentially more probability based, and they help to kind of calculate future events in regards to the current state that we are given. They're also able to be used to assess costs and profits based on the probability, and they can also be used to map out paths taken by different states. What we mean by that is the outcomes that each of the probabilities can relate to in a way that each state can be connected to one another through probabilities. And an example we have today regarding how this relates to the maritime industry can be seen right here. So consider that the New York City Yacht Shipyard receives an average rate of 45 vessels per year. There is one berth that can serve the vessels that enter the shipyard. The berth has an average service rate, of 50 vessels per year. This system follows an exponential distribution. So essentially, this is how we can apply operations research into the shipyard management section, where we use the number of vessels per year that the shipyard receives and the average service rate to calculate whether this shipyard is operating effectively enough. And so, with that being said, the next slide has these values. So we are given the average arrival rate, which is 45, the average service rate of 50, essentially our mu and lambda. We also know that there's only one berth, so which means there's only one server here, and therefore we use the MM1 model based on what the queuing theory formulas and parameters say. We find rho, the effective arrival rate, to be, or not the effective arrival rate, but our value that tests like how stable this system is, and we find that 45 over 50 gives us zero point 0.9, which is less than 1. This means that this system right now, this shipyard, is stable. Additionally, we can also calculate for L the average number of units in line and W the average time spent waiting in the system. And we see this is just a hypothetical situation, obviously, but we see that in line it'll be 9 vessels that'll be waiting for service, and then the average time of these guys will be spending in this system, both in terms of getting the service and waiting, will be zero point 0.2 years. Now that's just a hypothetical situation. Obviously, ships won't be able to wait for that long, and there will be, if it does, then there will be more than just 9 vessels. But this is how we an example of just how we can use queuing theory, an operations research tool, to help essentially make decisions and see whether the shipyards are optimal and are operating at their most efficient rate. So some concluding remarks of operations, how operations research can help solve problems in both marine engineering and shipyard management, is that they can help extensively in that they provide measurements of how efficient a system is without really essentially providing using too many. Isn't as expensive, if you will, as you can literally just make simulations using software such as Simulate or even the Excel sheets to essentially help you deduce like how efficient the system is. They can help to assess costs and profits. They can also provide a way to predict your outcomes and help personnel converge on the most optimal decision. What that means is basically it allows us to determine the most optimal decision based on probabilities and just data itself without really essentially have we can basically have like a little fortune teller to help us make the best decision to ensure that we will profit or reduce our costs as much as possible in the long run. Thank you very much for your time. Have a great day.